question number one would be is you have two motors. They're 28120, three-phase system, and you are supposed to, one of them is A and the other one is B, A and B motors, and we're supposed to size the overcurrent protection device for these motors, the conductors, the disconnects, the controller, the overload, and the equivalent grounding conductor for these two motors. That's kind of the requirement. Make sense? We've done that before. There's one little, again, if you don't have this graphic, guys, it will be PDF on the network for you. So don't sweat it too hard. Just understand it. It will be PDF. We have a starter disconnect combo. It's sitting right there. You're looking at it right there, guys, on that desk. That's what we're sizing. There's one little disclaimer. We are using the worst cable that you can ever imagine, which is NM cable. So that will force you to use 60-degree columns from the get-go. Cool? The voltage, we have done this example, guys, with 24120. We're doing it with 28120 three-phase panel. We need to size these for the two examples. Any comments before we go ahead and start? That's all the calc that we do, guys, is sizing. We're engineers and designers. They ask us to size conduits and conductors and so forth. Okay, so that's example number one. Comments, questions about example number one? You do have the description in front of you, guys, with it. For example, the example that we're using, it's a 10 horsepower, and this baby here is a 5 horsepower, 5 horsepower, 10 horsepower, 5 horsepower. Connected, one of them is 120, the other one is 208. Both of them are single phase. How do you get single phase 208? Anybody? How do you get single phase 208? You get 2 watts, right? From a three-phase system. That's single phase. The power system is 28120 three-phase. The wiring method is NMB. Find the following. So that's what you're going to see, guys, on the test. Question number one. Any comments before we go ahead and start? Okay. The first thing that I would like to do, and I cheated, so I have some stuff already written here. The branch circuits. For the branch circuits, guys, you need to go, like we talked before, you need to go to take the 10 horsepower motor into the 430.248 under the right voltage, the voltage that we're doing for this particular, for the first one, the voltage is 208. You need to go under 208. 430.248 under 208 volt, it will get you a healthy 55 amps. 55 amps. A healthy 55 amps. Any comments, guys, about this one? Find the full load current first, and I'll give you enough time to write. After you find the full load current, here's my full load current. Multiply it by 1.25 because motors are assumed to be continuous load, and that will give you a 68.8 amps. 68.8 amps. What's your reference? 430.22. Your reference is 430.22. Then you take your 68.8 amps, take it to a 334.80 NM cable. That to go to a table for NM cable. That will give you a number for this particular one, number 42 AWG NM cable 42. I want to remind you guys, we go to a 60-degree column here, 60-degree column. When you go to this table, B10.15, B16, because NMB 334.80. If you go read that one, it tells you NMB always, when you size, you have to always use 60-degree column. Because it's not a good cable. The answer is not more robust like MC cable. So then you limit the amps to 6-degree column. Residential, most of what we do is practically type 1, type 4, type 3, 4, and 5, and mostly type 5 building, which is wood buildings. Any comments, guys, about this one? Any comments? Any questions? Straightforward, right? We've done that before. Now, the second thing that we need to do, we need to size the overcurrent protection device. The same thing, guys. You take the 55. Here's my 55. Multiply that 55 by 2.5. I'll tell you where you get the 2.5 in a second. That will give you 137.5 amp. The DC code book guys says if it's not a standard, do not cry, go up. So you take the 137.5, take it to 240.6. You guys remember that? And that will get you a healthy 50 amps and one in front of it. 150 amps. Two-pole circuit breakers. Where do you get this info? 430.B2. 430.52. I'm sorry. 430.52. This is 52. 430.52. Any comments, guys? Any questions? How to size the overcomputation device for it? Go up on the test because sometimes you go up, sometimes you go down. Write yourself a note, guys. When we size the brand circuit for motors, go up on the overcomputation device. The 2.5 is coming directly from right here. You go to this table that you guys highlight, single phase, phase you 2.5. And to answer my friend Adam, why did I go to 60-degree column? If you go to 334.80, it will tell you you have to use 60-degree column for sizing, but 90-degree only for derating. So don't get confused. This is derating. This is sizing. And you guys remember how we distinguish clearly between derating and sizing. Any comments, guys? Any questions? So these are the two that you need to be able to. And I hope the first time you guys highlight these tables because we're going to be referring to them over and over as we go through the whole year. Let me know when you're done. I know I'm cheating, so I have some of the stuff already done for me. Another thing I want to show you too, I also have it here. Full load current. This is your full load current, guys, for the 5 horsepower, 56. For the 10 horsepower, 50. 5 horsepower, 56. 10 horsepower, 50. The full load current, which table to go to find the full load current for my motors that we were just looking at. That's where the 10 horsepower came to be under 208. So under 208, can you guys see that? Under 208, the 5 horsepower will give you 50. The 5 horsepower will give you 55. That's a 55. The 5 horsepower, it's not 50, not here. That will get me at 55 right here. That's where the 55 came to be. Because we're doing a voltage, for this example, we're using this voltage. Can you guys see that? This was highlighted from the example before that we did. We used 30, so we're using 208, we'll give you 55. Everybody knows how to use this table, 208, where you get that 55 from the tables. Okay, now let's go to the disconnect. The disconnects, gentlemen, the DC code book very clear said, oh, by the way, use 1.15. Where do you get the 1.15, guys? You get it from 430.11, so you take 55, multiply here, that will get you 63.3 amps. And then you take the 63.3 amps, take it to the 3-12, like we have done before, that will get you 100 amp disconnect. 100 amp disconnect. Yes, since you guys don't have disconnects, can you write yourself a note for the sizes that you guys are going to have? The sizes of disconnects are 30, 60, 100. Can you write yourself a note? You really don't have to, for dwelling, you don't have to go higher than that. So if you're less than 30 or 30, if you're between 30 and 60 or 60, if you're between 60 and 100, you are 100. That's all. Most of it dwelling between these three sides. After that, it becomes like multiple, for the most part, multiples of 100. Controller. The way we size the controller, guys, we go by, you take the 10 horsepower, in this case, by 10 horsepower, at the voltage that we have is 208 volt, single phase, and the DeWalt 6-4 will give you NEMA 3, NEMA 3. When you go there, make sure you go to 208 volt, or it says also 240 single phase. I want you guys to get the DeWalt. This will help you which column to go under DeWalt. You don't have the DeWalt. Now, if you don't have the DeWalt, or what you have to do, you don't have the DeWalt at this time, or what you have to do is then write this for me. Next project, the commercial project, you guys must have the DeWalt with you. If you don't have the DeWalt, all what you have to do is just write me that. A 10 horsepower at 208 single phase. That's the controller that I need. Have I made myself clear, guys, about that particular one? Please get DeWalt. DeWalt is going to be required next project for the commercial project and industrial. And the table is easy. It has a table. You guys go under the table that says 240. And under 10 horsepower, it cross-references itself with NEMA 3. I will give you NEMA 0, NEMA 00, NEMA 0, NEMA 1, NEMA 2, NEMA 3 sizes of these contactors. That's how they size them. Any comments, guys, before we move to the overload? Any comments before we move to the overload? Do you guys have enough time? Am I rushing you? So there is no Derek Mufford, no excuse not to get an A. I mean, you're looking at it exactly. So just to review it, write yourself a note. I know there's a lot of multipliers and a lot of numbers, guys. In our industry as designers, you work in the field, you have all your rules and regulations on the table in front of you and use it. My intention is, do you know how to use it right in front of you? If I was training you to be a master electrician and journeyman, number one, we don't go that deep in a lot of the stuff. They don't size UPSs like you guys are going to be doing. And number two, certain things you have to memorize it. Memorize the formulas and know how to find them, just because. But then we don't go that deep in the calculation. Okay, so that's my disconnect. Overload. The overload, guys, I told you from 430.32, overload always the full load amp on the nameplate. Now you will ask me, Chad, well, you didn't give us the full load amp, right? I didn't give you the full load amp. So that's when I stick a 50 amp here, and I'm going to call you, this is given. I will give you given full load amp. Did I give you the full load amp of these motors? Oops, I better have to give you the full load amp of these motors. Okay, overload size for 10 horsepower. Okay, so that's overload. So I will give you guys the full load. This is 50. Okay, so you're gonna go, when you know the overload, you have no idea what the temperature rise or what the service factor are. Did they tell you anything about service factor? Could be anything. What's your default if you don't know? 115. So you're gonna go to 115, guys. Take the 50. 115 and got yourself 57.5 amp and done. The last thing, guys, is equipment running conductor. The equipment running conductor is very easy. We size the equipment running conductor based on 150 amp. If you guys go to 250.122, it will get you a healthy number 6 AWG in NMB cable. Remember, we're using a cable, so that's not a conduit. So it's going to be part of that cable. I don't know if they make a number 6 equipment ground conductor with it, but that's the minimum size that you want. Okay. Now, the test guys have two motors and two sizes, right? Can you guys see there's 5 and 10? On the test, you will be only required to do the calculation for one motor. So for example, you will be doing 10. My friend Adam here will be doing 5. Did you guys see what I'm talking about? Because it repeats itself. I don't want you guys to do we already tested you. So did you guys hear me that yes, you have two motors, but the test you're going to size only for one. For one branch circuit. So I gave you for if you want to practice. So we're done. If you want to practice now, before we go to number 2. Oh, by the way, here's how you find the equivalent ground conductor. Here's my 100. So mine was 100 and what did they say? 150. 150. So I'm going to go change this one to 150. 150 amp. That will give me the same thing right in here. 200. That will still be number. That will be number 6. That will be number 6. Now. That will still be number 6. Here's where the overload protection, guys. If you don't know where the overload protection, I thought just these will all be on the network for you so you know where to go. That's where you got the overload protection. Okay, before we go to question number 2, that's it. You're going to do only one motor. So here's my advice for all of you. If you want to practice, guys, go back to that motor. See that one? Do you guys see that branch here? That motor here, why don't you use this one and practice? That will be your practice, right? Use this as motor B as a practice. Okay, so that's the motors. Let's move into. So we know how to do the motors. Let's move into another topic that we covered. Any comments about the motors, guys? Any comments? Any questions? So the same thing, guys. You have a feeder that powers water heaters, and there's 2 of them, and you, Adam, are required to do on the test. You're required to do how many? 1, because it repeats itself. The reason why I put 2, 1 for practice. So here's 2 of them. I have 8 kW, and this one's supposed to be at 3 kW. So if you guys want to practice that one, 3 kW, 24120, and we're doing a. So for the water heater, we're doing the same thing. We need a disconnect, we need a feeder, we need an overcurrent protection device, and a equivalent ground conductor. What happened to the controller current for water heater? It's provided by the manufacturer. Don't worry about the controller. Unlike motors. That's your question number 2, or B in your list. So we're going to go ahead and do the water heater A, which is 8 kW, 240 single phase. We need to do the calculation for the disconnect, the branch circuit, overcurrent protection device, as well as the equivalent ground conductor. Equivalent ground conductor. Okay. Shall we move? Yes. Okay. Here's the first thing we need to do. I want to quickly remind you, my friends, that we are still using an NMB wiring method, so we're still limited to 60-degree column. Next project, guys, you're going to use an MC cable, so you're going to you start using 75 or 60, depending upon the size of the conductor. Okay, so we got ourselves into. So the first thing you need to do is find the branch circuit, find the amps, because we size conductor based on amps, not kW. So I have an 800 kW, 8000 volt amp, divided by 240. That will get you a healthy 33.3 amps. When you size your conductor, it's continuous load 422.10A, your reference. So you multiply this by 33.3. You get yourself a 41.7 amp. 41.7 amp. And you go to 41.7 amps, go to 310.15 P16, 334.80, 60-degree column, and that will get you a healthy number 6-2 AWG NMB cable. NMB cable. Very clear, no gimmicks, nothing. Here's where we got that 125, guys. Oops. Here's where individual, can you guys see that's for appliances? And on appliances, that's where it got to 125. Your reference for 125, 422.10, it's an appliances. When you size it based on 125. I copied these one for you. Any comments? Let me know when I can move on. Good? Yes? No? Okay. So here's your cable. Here's where you reference where you get the 1.25. Then the second thing, we need to find the overcurrent protection device. I don't know if I have the reference for the overcurrent protection device. For appliances, guys, if your full load amp is 13.3, more than 13.3, then you can multiply by 1.15. So that's coming from 1.15. This number here is coming from 422.11E. That's your reference. Because it's non-motor appliances, no motor in it. So you take the 33.3 multiplied by 150. That will get you, okay, what am I, okay. That will get you, this is wrong here, of course. That will get you 50. Am I right here, 50 amp? Can you guys check that one for me? 50 amp. Anybody verified that math?
Yeah, 49.95.
Okay, let's use 49.95. 49.95, just for to make sure. So then you take the 49.95 amp. That'll get you a healthy 50 amp. So that's my 50 amp circuit breaker. Then what you need to do, gentlemen and ladies and gentlemen, here's my 50 amp circuit breaker. My conductor here is 6.2. My water heater, here's my water heater. And do me a favor, after you finish this, Karen, you need to go check, can number 6 get me, how much amp can number 6 carry? 310.15 B16 under 60-degree column. How much current number 6 can carry? 55 amps. 55 amps. So I'm good to go. Can you guys see that? That check. This is to check. Check if your conductor can carry. So Adam, I have a 50 amp circuit breaker protecting a number 6, and this number 6 can carry 55 amps. Am I okay? Yeah. If you're not, if you end up with 80, not 80, 40. If you end up with 40 here, you have two options. Either you lower the overcurrent protection device to 40, or you have to up your conductor. Do you guys hear me? So for example, if I use number 8, say use number 8. How much number 8 can give you, guys? Give me number 8. How much number 8 can give you? 40 amps. Number 8, 310.15 B16. Anybody? That will give you a number under 60-degree column. 4. So that will give you 40. Then can I put 50 amp on it? No. So this is the check. Did you guys see that on the bottom check? We're good. In this case, 6.2 is good. That's my overcurrent protection device. Disconnect. For disconnect, my friends, I use 1.25 to size my disconnect. 1.25, assuming it's continuous load, here is my 33.3. Give you 41.7 amps, and you take your 41.7 amps, DeWalt 3-12, that will get you a 60 amp 2-pole non-fused disconnect. 60 amp 2-pole non-fused disconnect. That 1.25 for the disconnect is from Chad. We're assuming it's continuous load and we're sizing 1.25 our disconnect. Would I ever use 1.15? Probably you would. But I size it like a conductor. The last thing, guys, for this is the equipment ground conductor. You take your healthy 50 that you've done, and that will get you a conductor number. One conductor number 10, AWG N NMB cable. We're using an NMB cable. We're using an NMB cable. Okay, so there will be 2 water heaters. One of you guys will size one size, the others will size the other one. So, if you want to practice, we're done with this one, guys. If you want to practice, you can go back again. So we did this one, Karen, for this. So you can go and use this one as your practice and do calculation based on 3 kW. Same thing. Am I making sense? We're not going to do it for the review because they're redundant. Okay, that's it for the water heater. Any comments, guys, about the water heater before we move into my next is electric furnace. Electric furnace. I have an electric, question number 3, guys. I have an electric furnace, a healthy, not so wealthy, just healthy, huh? Electric furnace. I have 2 electric furnaces. One of them, let's just make this one 65, will you? 65. 1A, 1B, of course. 1A, 1B. I'm only interested in A for the example. You guys will use the B as your calculation example. I need to size over conduction device, the conductor, the disconnect for that water heater, and the equipment running conductor. I'm still using the worst cable that I can do, which is NMP, and the wiring method is ROMX. Voltage is 240, 120, and the panels say it was 300 amp. We're going to do the same calculation for our water heater. Do you guys see the what we're trying to achieve? I know you're beginners to the design yet. That's what you're going to be asked. Different size. They give you different loads and size them. And the code, for the most part, I would say everything that we do, for the most part, 70% is the same. Do you guys see the redundancy? It differs is, do you multiply by 1.5 one time, or 1.25 one time, or 1.75 one time? And that's the knowledge that you have to do. And if you get confused, write yourself a note. If I do a motor with a circuit breaker, I multiply by 2.5. If I do an appliances, I multiply by 1.5. Okay, shall I move? Yes? Okay, next one. All right, so I have an appliances. Appliances, guys, is 422 as well. And since they're also heaters, we apply 424 also apply to them. So let's go ahead and find the branch circuit before we go and do any calculation. So I have my 95 here. I have a 95 amp. Multiplied by 1.25. This is from 422.10A, same thing for appliances. Give you 118.8 amps. You take your 118.8 amps, take it to 310.15, same thing, 60, that will get you number 1/2. They don't make them NM cable. NMB cable. I put question mark here. Be careful. If you don't believe they make more than larger than number 1. So what do you do? By the way, what do you do if they don't make larger than number 1 NM cable? Anybody? We switch to what? MC cable. So you can switch this one to a number 1 MC cable. Number 1/2 MC cable. Let's do that one. Or AC cable. Since we know they don't make them, let's make this one number 1/2 MC cable. cable. We're still sizing it based. Let's see. We're still sizing it based on the logs, guys. We're still sizing it at 334.8. We're still sizing it at 334.8. 424 also, since it's an appliance, is 424.3b. It's a heating element. You multiply 424.3b applies to it. Okay, so that's an appliances and a heating too. So two articles applies to it. Overcurrent protection device. We're assuming, guys, it's continuous load. It's an appliances, but it's a heating appliance. So they allow you to use 95. So you take the 95 multiplied by 1.25. That will get you the same thing, 118.8 amps. Your reference is 422, 424.3b. Will tell you to multiply by 1.25. You take the 118.8 amps, 240.6, that will get you 125 amp 2-pole circuit breaker. Then you put yourself 125 amp circuit breaker and your number 1/2 MC cable to feed your, this one will be feeding the 95 amp. If you want to do the check, you really, since we use a 1.25, guys, do I need to check? When do you check? Let me tell you why. What's the multiplier that you guys use for the branch circuit? 1.25. What's the multiplier that we use for the overcurrent protection device? 1.25. If the multipliers for the two of them are the same, there's no need to check because we use the same number. The one before we did the check, anybody knows why we did the check before? Because we use a 1.5 for the overcurrent protection device and 1.25 for the cable. So you need to make sure that they match for appliances. In this case, no need to check. If you guys want to go check, can number 1 out carry 125? Definitely does. At 60-degree column. That's what we size it here. We sized it before. So there's no need to check for the cable. Okay, so we size, any question, guys? We size the overcurrent protection device. We size the conductor. Why did I multiply by 1.25? If you guys go to 424.3b, it will tell you it's continuous load, it's heating element, multiplied by 1.25. Unlike water heaters on appliances, and they allow you to go 1.5. Go figure. Disconnects. For the disconnects, I use the same calculation, guys, 1.15, just to stay consistent. So we got the overcurrent protection device. Disconnect, so you can take the 95 here. Again, same calculation, 118.8 amps. 118.8 amps. Take it to the wall, get you a healthy 200 amp disconnect. 200 amp disconnect. And the equivalent ground conductor, very easy, 125 amp, 250.122 gets you guys number 1. One conductor number 1, 6AWG. We know they don't make this one cable, so let's go and make it in MC cable. In an MC cable. And let the manufacturer size it. We don't. If it's a cable, guys, we know that's the minimum size, so the manufacturer will most likely have a little bit bigger size than that, so be it. But we know it's our minimum size. It makes more sense if we're using a conduit and wire, then we have to size it and pull it. If it's a cable, the equivalent conductor, guys, comes sized by the manufacturer based on, almost based on these rules. And so either minimum or even larger, they put it. Larger is good.
So 200 amp, the next largest disconnect.
Yes.
Over 100.
Yep. They don't do 150, unfortunately. Yeah. 200 amp. If you're in doubt on the test, 200, they have 400 and 600, 800, and then 1200, and then I can't remember after that where it goes. Electric furnace. Questions about electric furnace. So what I would do if I were you guys, the second example of the furnace is use it as, practice. Can I move to the next one, Adam? Okay, so my next example, number 4, guys, is an AC unit. AC unit. Okay, I do have a couple of things for my AC unit. I have, same example, guys. I have an AC unit, air conditioning, rated load amp or load current 41. Let's make this one, if you guys want to exercise for it, let's make it 55, will ya? Rated amps of 55 for that boy. I'm going to only do A. You guys will do B as an exercise if you decide to practice. Rated load current on the nameplate given as 41 amps. 240 circuit breakers we're using. We need to size the overcurrent protection device. We need to size the conductor. We need to size the disconnect. The 3 would be the disconnect, my disconnect. And I need to size the equipment ground and conductor. Same thing. I'm still using that worst cable that God created, which is NF cable. My article is 440. Cool. Again, this will be PDF. You guys have a copy of them before, and you will have them on the network. So don't sweat it too hard. You don't have to sit there and sketch that one. Take you half an hour. Any comments what we're doing, guys? 2 examples. We're doing 1. On the test, you will do only 1. So in reality, on the test, you only have 4 problems, guys. Right? 5 problems. The rest of them might mean a lot, but you're only doing 1 of them. Okay, let's go ahead and start. Branch circuits. For branch circuits, guys, 440.32, it tells you it's continuous load, so magic number. If you ever have to guess when you size branch circuits, guys, always guess 1.25. 41, that will get you 51.3 amps. You take your 51.3 amps. Since we're using Romex, then we have to go to 60-degree column. Okay, that will get you number 6-2, 2 conductors, AWG and MB cable. NMB cable. That's it, 1.25. That's your conductors. Now I want to bring to your attention tomorrow, guys, one little thing. This number here, this number right here will be called minimum circuit ampacity. You guys hear me? This number will be called minimum circuit ampacity. So, Dirk, my friend, when the manufacturer have on the nameplate minimum circuit ampacity, that's also on the test, by the way, on the theory test. Minimum circuit ampacity, do you need to multiply by 1.15 or 1.25? No, it's already done for you. You guys see where after you multiply by 1.25, that number is called minimum circuit ampacity. So you don't have to multiply by anything. I'm not giving you minimum circuit ampacity though. I'm giving you rated load current. So that's why I multiply. Okay? I'm just going to write it down, minimum circuit ampacity. All right, moving into the next one. Overcurrent protection device. The NEC code book, guys, if you don't know what the maximum overcurrent protection device for the air conditioner, if you don't know, big F, which almost always has to be on the nameplate, then you multiply by 1.75. Where does the 1.75 get to be? 440.22a. So let's go multiply this 41 by 1.75, my friends. That will get you 71.8 amps. 71.8 amps. 240.6 here. 240.6. If you take it to 240.6. Same location that we've been. That will get you guys a healthy, when you go, you're going to go lower down to 70 amps. 70 amps. two-pole circuit breaker. 70 amps two-pole circuit breaker. 70 amps two-pole circuit breaker. 70 amps two-pole circuit breakers. 70 amps two-pole circuit breaker. Any comments, guys? Any questions? Why did I go down? If you guys read 440.22, it doesn't tell you to go up. So if you can't go up, you can't stay where you are. What are you going to do? Think about it. You can't go up because you're not allowed to. You can't stay where you are because they don't make the size that you're looking for. So your only option is what? Going down. So you go down to 70 amps. Your reference, oh, now, having said that, please write yourself a note here. This will be called maximum overcurrent protection. MOP, maximum overcurrent protection. On the nameplate, this will be listed as maximum overcurrent protection. Anna, it's on the test tomorrow. Not tomorrow, on Friday. It will tell you what is MOP. There's actually a match. What is MOP? Maximum overcurrent protection device. That's the size of the fuse or the circuit breaker that you can use. So in real life, Derek, these two numbers will be given to you in the nameplate. All what you have to do is just size them, stick them in there. Okay. Number 2. Can I move to number 3, please? Yes. Okay. Number 3. Number 3 is your disconnect, gentlemen and ladies, and gentlemen. You're going to take the 41 amps, same thing, 1.15. What's your reference? 440.12a. That's where you get your reference 1. You got yourself 47.2, I believe, 47.2 amps. Then you take the 47.2 amps, DeWalt, same thing. That will get you a healthy 60 amp, two-pole, non-fused disconnect. 60 amp, two-pole, non-fused disconnect. Why two-pole, two hubs? Why non-fused? Did this say anything about fuse? We already sized the circuit breaker. We don't need a fuse. The last thing is piece of cake, guys. The equivalent conductor. You take the 70 amp, the overcurrent protection device, to 250.122. That will get you a healthy number 8 AWG in NMB cable. Right? Now, if the manufacturer decided to stick a wire higher than that, be it. Since it's a cable and we have no control over how to put conductors in the cable, and you buy enough. Our size that for this project was, what was the size for the brand circuit? The size was 6'2". So they might, with 6'2", they might, typically they might put with 6'8", that's about right. With 6'2", they put number 8 equivalent conductor bearing. Any comments, any questions, guys, before we move into my last example? So that's for AC units. Does it make sense? Yeah, Matt? Am I the only one who's excited about all this calculation or no? Now, you're going to Mashad, Adam. And all of you guys, if you're in the field, if you think when you go sit in an engineering firm, you're going to do all this calculation, think again. These will be done by a bunch of engineers before you guys. They have tables, like Mashad will have a bunch of tables for you. And they say, if you have this size of chiller, here's the size of the feeder and the conduits and the overcurrent protection device that I use with it. To standardize the process, including voltage drop, including continuous load, including bundling, whatever. So, but it's nice to know why we do what we do, guys. It makes you a better engineer, a better designer. If you encountered something that's not in one of these tables, or if you work for a smaller firm that doesn't have these schedules, most engineering firms, guys, major engineering firms, they have schedules. They already developed their engineer set, exactly what we've done. So as I use, and then you can use them. But what your job, guys, to understand these concepts, which is not hard. Okay. Any comments, any questions, guys, about these AC units? My next it is going to be a residential calculation. For residential calculation, you, gentlemen, ladies and gentlemen, have done this we've done an example like this. You're doing it right now with Excel for your friend Chad. You're supposed to develop this in Excel. So what I'm giving you guys, I'm giving you the following. You have the information right in the front of you. I hope it matches what I have. Example number 5. We have a unit. It's an apartment building, a riser. Can you imagine a riser here? And you can imagine how many units in these risers. 1, 2, 3, 4, 5, 6. So here you go. 1, 2, 3, 4, 5. 5 in each, and this will make a garage. Shall we? Make the garage at the bottom, and put 5-story building, 2 apartments, 1 in each. So that's right. Typical. Here's 1, here's 2, all the way to 9 and 10. 10 units. Unit. Square foot, each unit they're richies, so they're living in an apartment of 4100. That's almost as big as my house, if not bigger. Don't ask me why, they have cash. So 4100 square foot, that's a big size apartment. A lot of apartments are barely 1,000, 1,200, maybe 2,000. Okay, the voltage is 24120. Each one of them has an AC unit of 42 amps at 240, heating 8 kW at 240, range 90 kW, that's a big range, dryers 6 kW, garbage disposal 2 kW, dishwasher 1 kW, water heater at 240, 7 kW, pump 5 horsepower at 240. Cool. These are all the loads that we have. And we need to size the service for this apartment building. You guys will be called up on to size the service for this apartment building. Don't I have this information here, guys? I do have it right. This information, all the stuff is right here too. You don't have to write the numbers. E has all the information that I wrote on the board. So let's expedite the process for you. So you can see that, right? At the last time, it has all this data. Exactly as it will appear on the test. That's how you're going to see on the test. Okay, so questions? So we have this type of building. So let's go size. Size the service. We're interested in sizing the service. The first thing you do, guys, and I hope this will be also a review for you guys to do the calc. General lighting and receptacles. The NDC code book, guys, have a table 220.12. Adam, you're almost done with your load calc. You've just done this many times with us, right? This third time. Hopefully sticks. And you're going to do it 2 more times in the commercial industrial. Slightly different, though. Okay, gentlemen and ladies, or ladies and gentlemen, take the 3-volt amp from the table 220.12, multiply it by the square foot of this fat, fluffy apartment. That will get you if you do that, don't forget also to multiply it by 10. Anybody knows why 10? Why did we multiply this by 10? That's 10 units. 10 units, an apartment, 10 flats, like the British would say. 123 kVA. So 123 kVA will be allocated to, these will be allocated, guys, just to the general lighting of that apartment building and receptacles. Now, Derek, my friend, the 3 is coming from this 220.12 for dwelling. The 4100, 4100, that's square foot of the building. The 10 because we have 10 units. Straightforward. Then you have to go small appliances, branch circuits, 220.52a will tell you every apartment shall allocate 2 circuits, each one of them at 1.5 K, and we have 10 of them. So that will get you a total of 30 kVA. 30 kVA. Done. 30 kVA. So want to move? Okay. The system not moving with me today. There you go. Okay. That's your small appliances circuits. my friends, laundry, each one of them is going to have a circuit allocated to laundry. The laundry is allocating 1.5K. Each one, there's 10 of them. 220.52B tells you this. And I'll get you 15 kVA for this apartment building. 15 kVA. Straightforward, guys. Directly from the NEC code book. No gimmicks, nothing.
For number 3 on this sheet, it just says building demand load for dryers.
No, that was just for the first one.
Oh, okay. All right. Yeah. Oh, yeah. That's right. Okay. Yep. Yep.
Oh, did I put wrong reference?
You're good. You're good.
Okay. All right, so we add them up. Now, any question is straight from the code, right? These are all directly from the code. That's what you guys are building for. Then, here's what you're going to do. Then the code says, step number 5, add them up. Add these 3 up. So I have 123K, add it to 30K, add it to 15K. When you do your math, you're going to find 168 kVA. Add them up. Then you apply demand factor. That's, I don't know if that's what you're doing. Demand factor 220.42. 220.42, the code says there's highly unlikely all of them will be turning their lights and receptacles on at the same time. Right, for all these 10 units, unless they're having a big party that day, that everyone in the apartment's having a party, or unless you have 10 kids in every apartment. Could happen these days. So, because of all of this, you can derate, cut it down a little bit, reduce it. Where would these derating came from, guys? These are statistical and experience. You know, statistically speaking, after you design it and they go measure the actual load, they came up with that there's no way you can get 168 kVA for lighting a receptacle for this part of our apartment. Okay, derating. How do we derate? You take the 168K and then you're going to split it into the following. The code says, guys, the first 3 shall not be touched. That's the first 3. Then, anything higher than 3 up to 117K shall be multiplied by 0.35. Then, all these are coming from where? From here, guys, right? Then, you take your 168 minus 120, right? You multiply this one by 0.25. And then you add them up. That's how you apply this table. When you add them up, you end up with 56 kVA. 56 kVA. That's the number that you're going to carry downstairs with you. Anybody knows what the 117, guys, the 117 is coming from? The 117, if it's confusing you, it's coming from 120 minus 3. That's where the 117 came to be, from 120 minus 3. That's how you apply this table. The first 3 leave them alone. The first 117, because the 3 added to them is 120, cut it by 35. Anything higher than 120, which is whatever you came up minus 20, cut it by 0.25, add them up. That's it. That's a demand. Can you guys, I hope you appreciate it. Instead of sizing for 160 kVA, now we're sizing for 56. 1/3, almost 1/3 of the size. What does that mean, guys? That means 1/3 of the equipment, 1/3 of the price, 1/3 of the labor. A lot of interesting stuff happened. Okay, shall we go to the next one? Can I have thumbs up? Yes, down.
So you take the 3 plus the other one after you did all this.
Yeah, you take the 3, you add to this, you add 56. So if you take the 3K,
17 times 0.35 is 40.95 kVA. And 168 minus 120 would be 48 times 0.25, which is 16.8. I got 60.6 1.75.
Did they screw up? Anybody somebody verify this, please? Can you guys verify this? I could have screwed up with the math. 17 point, where's my calculator? I could easily screw up. Did you come up with what?
55.95.
So, okay, 55.95, so that's 56. Okay. So I have two people verifying it, Derek. Then you must have, so you take 117 times point
Oh, wait, okay.
35 equal 41. This one is 41. 41, right? And then this one is 168 minus 120 times 0.25.
Yeah, no, sorry.
This is a 12.
One man addition.
Yeah, that's about right. 41 plus 12 plus 3.
I told to add the answer for and the,
Okay, no biggie. That's why I would rather you do the mistake here than on the test, right? Okay, let's go to the next step. The next step, okay, by the way, this is what we're sizing, guys. You will be required, we forgot to tell you what you need to size. You will be required to do the overcome protection device, the service size, the neutral and the main bonding jumper. The neutral and the main bonding jumper. That's what you're required to size at the end. Okay, so let's go back into, let's go to the ranges. For the ranges, guys, remember that table that talks about ranges? Here's the table. I have, do you guys remember the size of my range? The size of my range is 119, 19 kW. And I have how many of them? I have 19, I have 10, 19. Here's my 10. And 19 will be 25. Can you guys see that? I have 10 ranges. They're all 19 under C, so their demand is 25. Then you up it 5% for every kW more than 12. That's how we do it. So from the get-go, your 10 give you 25. Everybody knows why the 10 gave you 25 under C, because they're all under C. So let's go back and do the math on that one. So if you go for 19, I have 19 kW, 19 kW. That's definitely under C. A and B shall not be used, so they'll give you 25 kW from the get-go. That's a 25 kW. Then, step 2, you take the 19K, subtract from it 12K, that's why, because the code says so, equal 7kW is the difference between the 12 and what I have. Then, take every 7 kW, multiply it by 5%, because that's a difference between what I have and what the 12 is. That will get you a 35% increase. So that's your increase. Your total demand, gentlemen, ladies and gentlemen, is 1.35 multiplied by 25K. And your total demand for this step is 33.8 kW for all the 10 of them. For the 10 of them. Can you guys appreciate that? You know what you want to do if you want to take Adam, multiply the 19 by 10. That'll get you 190 kW, went down to 33.8 kW. Major difference. Major difference for ranges. Major. From 190, because there's 10 of them, down to 33.8. So that's the number that you're going to use for sizing your service. The number that you're going to be using for sizing your service. Do me a favor, can you leave space at the bottom here when you do each step, because I want to just find a little line because I want to do the neutral, or you can write it on a different color. So I'm going to calculate the neutral later on. Just one line underneath it. That's why I leave these one lines. One line. Okay, here's how we calculated this. Any question, guys, about the ranges? So that's a calculation for ranges. ranges. Let's go to Mist Dryer. Mist Dryer 220.54, 220. This one is 220.61B, guys, is for the neutral. We're coming to calculate the neutral, so leave it. The rating factor for dryers, I have 6 kVA. The code says, guys, 5K or the size of the dryer, whichever is larger. I have 10 of them. For 6 kVA, 6 kVAs, the rating factor is 50%. Highly unlikely, Karen, that you and I and everybody in the apartment building will be doing our clothes, washing our clothes at the same time, right? That would be. So what you do, then you take your 6K, multiply it by 10, anybody knows by 10, because there's 10 of them, multiply it by 0.5, and ladies and gentlemen, you get yourself at 30 kVA. That's the size that you're going to carry, the size you serve for the dryers. That's your size for the dryer. Matt, do me a favor, leave a room here for one more line because I'm going to do the neutral. We're going to size the neutral in a second. That's your demand for the dryers. Can you guys see how, like, Adam, how do you eat an elephant? One bite at a time. It looks like big, but when you take it step by step, guys, not really that complicated. Okay, dryers. What else do we have in this building? Ask yourself, what else do I have in this building? Any question about the dryers before I move on? Everybody's good with dryers? Cool. Let's go to the next type of load that we have. The next type of load is heat-cool. For the heat-cool, guys, they are non-simultaneous load, 220.60, 220.51, and 440. 220.60 tells you guys, choose, do the math for both of them, pick the largest heat or cool, the largest of the heat or the cool. Okay, for heat 240, I have 8 kW heaters, 8 kW heaters, 10 of them. That will give you 80 kW. That's my heat. My cool, my AC, did we give the amps for the AC? The AC amps are given as 240, AC amps are, how much? 42, yeah. For the AC units, guys, I have a 42 amp, multiplied by 240, divided by 1,000 because we're going to convert it into kVA. That's the kVA of one AC unit. Don't forget to multiply this by 10 so you can get the 10 of them. That will get you a healthy 100.8 kVA. Okay, now choose the largest of heat and cool. Heat and cool, and that will get you the largest of the two is this kVA. The cooling is the largest, so that's the one that you're going to carry for this step, because it's highly unlikely that you will be heating and cooling the building at the same time. Would you? You must have lost it if you're going to cool it. Yes.
Like if you divide it by 1,000.
Because all the calculation that we're doing in what? Okay.
Yeah.
So in order to convert it, otherwise, you'll be adding cents to dollars. 10 cents plus $10 are not 20. 20 what? Cents and dollars. You see what I mean? That's why we divide by 1,000 immediately. Because everything that I'm doing calculation, guys, volt amp, guys, doesn't mean much when you size for buildings. It's always kVA, right? Because the buildings are big loads, kVA. Okay, so step is 8.8, 100.8. Next step, so that's a heat cool. Fasten in place appliances. Fasten in place appliances 220.53, guys. There's some of them are 120, some of them are 240. Big deal because you're going to see what's going to happen later on. So I have dishwasher 1K multiplied by 10 equal 1K multiplied by 10. Then that's my dishwasher. Then I have garbage disposal 2K multiplied by 10. The garbage disposal is bigger than my dishwasher. Great. And water heater, 7K multiplied by 10. Ladies and gentlemen, that will get you 100 kVA. Demand for demand, which will be step number 12. That will be your demand. The code says, guys, if you have 4 or more fastened in place, you have to cut it by what? Anybody remember that number? 0.75. So then you're going to take the 100K, multiply it by 0.075. That's coming from 220.53. And that will get you a healthy 75 kV and A. And that's the number that you're going to use. Do me a favor. Keep room here because I'm going to do the neutral here. Keep room for the neutral. I keep a little bit room here because I'm going to do the calculate the neutral.
Is it 75% or 7?
No, 75 kVA. Oh, 75%. Oh, what the heck is that? That's not a 75%, chat. 0.075. Thank you. 75%. 4 or more, you cut them by 75%. Do we have 4 or more? Look at this. We have only 3, Chad, but we have 10 of each. We have 30. Remember, Adam, when we were doing the apartment, well, we derated for the whole building. For the apartment, we did not derate because we don't have more than 4. Okay. Any comments, guys? Did they go fast? Slow down, Chad. Makes sense? You use 75% if you have 4 or more. Okay, motors. Now let's going to go to the step that talks about motors. We talked about fastened in place appliances. We're almost there. Motors. I only have one pump. One pump. It's 5 horsepower. It's a 5 horsepower pump. You're going to go to 430.248 on the 240, guys, or 230. You're going to find the 28 amps for it. You need to find the amps for the motor. 28 amps. Then, since it's the largest, we're assuming this is the largest motor in my system, so I'm going to take 1.25 times 28 times 240. Divide this by 1,000. Remember why? Because we're calculating everything in kVA. Plus all the other motors. There's 0 other motors. That will get you an 8.4 kVA. So this baby will be seen as an 8. Anybody knows why I multiplied 28 times 240 divided by 1,000 to make kVA for one motor? Why did I increase 1.25 on it, guys? Because you take the largest motor, multiply by 1.25. What's with the 0 here? There's no other motors sharing the same feeder.
Were you timing by 0 or adding by 0?
Adding by 0. Oh, you don't multiply it by 0. You add you add the other motors, kVA for the other motors, which is 0. So that's the motors. If there are 4 motors, you take one of them, up it 25%, add the other 3. Ladies and gentlemen, we're almost done. Then you're going to add them up. Here you go. You go to these steps, and we're going to write them and add them. So I'm going to start with, so remember, I'm going to start with 56 here, 56K. 33.7K, 30K, 128K, 75K, 88.4K. When you add them all up, you're going to end up with 304 kVA. That's your total for the whole building. That's how you're going to size your building. Any comments, guys? Any questions? Just add them up. Add them up. So you can see we add the small, light and small appliances, range, dryer, heat, cool, fasten in place, motors, Add them all up. 304, yep. Looks like 6, isn't it? I'll give you 304. Let's write it down one time here. 30. Why can't I get the 0 to close here? 04 K3A. It's hard to write with that. You lose your synchronization after a while with that, man. That's a 0. Okay. Now, please leave room here because I'm going to do the neutral on the side here. I'm going to do the neutral on the side. All right, let's go size now. Any question, guys? Any comments, questions? Almost done, like I said. Okay, we're going to go size. Now, service, entrance, equipment, disconnect, overcome protection device, and conductors. The first thing you need to do for this baby is take the 304K divided by 240 to find the amps. That will get you a healthy 1267 amp. 1267 amp. Then you take the 1. So that's the panel size 1267 amp. The wall 3-13 will get you 1600 amp. 1600 amp panel. And overcome protection device, the same thing, guys. 1267, 240.6 give you a 1600 amp. Huh? This is from 240.6, you get your 1600 amp. In reality, guys, here's what you do. In real life, these will be adjustable circuit breakers. You will tweak them down into, most likely into, in this case, 1300 amp. Tweak them down, adjust them down to 1300 amps, because there is no 1300 amp circuit breakers. They don't make them fixed. They make them adjustable. No, it's 1600. You buy a 1600 amp circuit breaker. You dial it down just above this one. I have 1267. That to be close to 1300, right? You dial the 1600 down to what? To 1300 and size your feeders based on that. Size your feeders based on that. But we're assuming these are fixed circuit breakers, non-adjustable, highly unlikely though. So that's the size of the panel. Now tomorrow, guys, for that test, how are you going to size your panels for me? Make them the same as the overcome protection device. Just match them. They don't have to always match. Match them. So for example, Adam, panel size and overcome protection device go to 240.6 for now. Let's go back down into the conductor size. Now the conductor 240.4C, guys, match overcome protection device. So I'm going to go match my overcome protection device. I'm not using adjustable, so I'm going to have 1600 divide by 4 because I need to parallel. I have 4 runs. So they give me 4 runs of 400 amp. Take this one to table 310.15B16 under 75-degree column. Under 75-degree column, that will give me 4 sets. 4 sets. Each one of these sets is 2 conductors, 600 KCM, THHW. What happened to why 2? Hot 1 and hot 2. What happened to the neutral? What happened to the neutral? We're going to size the neutral in a second. What happened to the neutral? We will size the neutral in a second. So
you divide it by 4. If you, because I'm just seeing on the last example that you did, you divided it by 10.
Because we were doing 10 sets. We're paralleling 10 sets. I'm erasing it right now. How many sets can you parallel? Remember, guys, when you parallel, you will end up with a number here that's close to 400 amps. Okay. What was the size that we did last time? Do you remember?
It was 3,000.
That's it. That's why. Divide by 10 will give you what? 300. You're going to hover around 400 amps. That's what you, when you pedal. Why? Because 400 amps, guys, 300 to 400 amps give you 500 kcm to 600 kcm. These are the largest conductor that easily work it. You can work with easily in a conduit. You go higher than that, it becomes tough to work with them and put them in a conduit. You can see the key point is when you pedal, we'll talk about this one in the commercial. You will hover over between 300 and 400. That's what you do. You basically, when you take your number, divide it by 300, say 300 or 400, and see how many runs you can get.
So that would have been, so that one would have been 10 sets.
That,
Whatever.
yeah. So here's the sets. Here's the 4 sets that I have. Why did I divide by 4? Because if I divide by 4, they give you 400. 400 give me 600. That's a good size to pull. Can I go divide it by 5, will you? If I only do 5, what would that be? Divided by 5. What would the 16 divided by 5 would be? That probably would give you 320. 320 will give you 5 sets of 500. That's okay too. You can see what I mean here. And the reason why I picked 4 here, because if you divide 1600 by 4, it's easy number, solid number too. Okay, so you're going to end up with these 4 sets. 4 sets. Any comments, guys? Any questions? 4 sets. Any comments? Any questions about that? Now let's go size and neutral. Before we, you guys want a quick break? I only need 10 minutes. You have to? Okay. Let's take 5 minutes. Let's take 5 minutes. Thanks. All right, so thank you. Okay, now the next thing, guys, I want to do is find a neutral. I want to remind you for the neutral, guys, anything that's 480 will be dropped. For example, this load here will be dropped from the neutral. The pump will be dropped. The AC will be dropped. The heating will be dropped. The range and the dryer, we take 70% of these, right? Anything 480 will be dropped. So just a reminder, I dropped the AC, my AC is dropped, my heat will be dropped, pump will be dropped, and also the water heater, anything 240 will be dropped, except the dryer and the range, because they are 240, 120, there's a 120 with them. We count only 70% of them, okay? And that's what we're gonna go. So go back, guys, to the steps that we did, step by step. And let's go size the, okay, so for this step, for step number 6, let's go to my step number, where am I here for, okay, residential, okay, for step 5, okay, I grab that, ranges. All right, so step number 6, guys, here, do me a favor, so then, the demand for lighting and receptacles, all your lights and receptacles are running 120. So they will be seen by the neutral. Do you guys agree with me why they should be seen by the neutral fully? So for this step, all what you have to do is do me a favor, put neutral here and count everything that we did. The same number, 56 kVA. That will count towards a neutral. All of them will count towards a neutral. Maybe we should put them under, instead of here, I will put them under step 6 because that's how they should be here. So I'm going to go take this one. Oh, come on. What do you all down? Where's it want to go? So my neutral. Here's my neutral. And the size of my neutral would be, what did I say? 56 kVA. Okay, any question, guys, about this? Straightforward. All of them will count the same, no changes. Same thing. Let's go to step number 7, will you? Step number 7, that's where the neutral start differing. Step number 7.
Was the last one you did the grounded conductor?
The ground, yeah, we're trying to size the grounded conductor. With the same neutral, so for all the steps up to 6, it's going to count exactly the same calculation. So you don't need to repeat it. 56. Okay, let's go to 7. For 7, step number 7, guys. Step number 7 for the neutral, I'm going to put my neutral right here. Here's my neutral. The code says you take the same number, 3.8K, and cut it by 0.7. That's from the NEC code book 220.61b. And that will get you a healthy 23.7 kVA. 23.7 kVA. Why did I multiply by 0.7, Karen? Because the code says so. Where does it say so? 220.61b. That's all. Chop it by 70%. But the same, can you see the same calculation says the same, right? The only thing you do at the end, you chop it by 70%. Why do we chop it by 70%, guys? Because ranges are for, oops, not 240. 240-120 volt load. So they have 240 for the heating elements and 120 for the control. Same thing for dryers. They have 240, 120. They call them 240, 120. They're not just 240. They're 240, 120. Okay? Meaning they have a neutral on them. All right, so next, so we'll get that one. Dryers. Dryers, right? Do me a favor. Right here, it's a 240/120 volt system. That's why they count. You do the same thing for the dryers, guys. You take a step here. Here's my neutral. My neutral is 30K. Multiply this one by 0.7. That will get you a healthy 21 kVA. 21 kVA. That's it. Do you see, guys? Can you guys see the same calculation? Same calculation. The neutral, you just take 70% of it. Why do we count it 220.61b? Why 220.60b says so? Because when you wire them, you send a neutral there. The way they do it, the dryers, guys, the way they manufacture them, the heating element and electrical dryer, they run at 240 because it's a big load. And the motors, remember the dryer has a motor that rotates things and flip it around, right? Flip things around as you dry them, move them around. That runs at 120. And some control too that runs at 120. Cool. Okay, so now moving into heating, cooling. Now the heaters, they're pure 240. AC pure 240. When I say pure 240, there is no 120. You send just 2 hots to them. So this step will count when it comes to the neutral. So if I were you, I would come over here. We're sizing a neutral. What step here? Here's my neutral. And I would say big fat fluffy 0. Why would I put 0 here, guys? So I know I accounted for them. They don't account for nothing. They are 0. Okay? That's what they are going to account for. 0. When you were doing your math, Adam, and I told you to put zeros, when you put a 0, guys, you tell yourself, yeah, I know. When you leave it blank, I don't know. When you put 0, you know that it doesn't count. That's what 0 means. Okay, did I step? Okay, fasten in place. For my fasten in place, there's a little calculation for fasten in place. You will look at them, 120, 120, 240. Oops, what happened to the 240 here? So this one is going to count as the same thing. There is 1K times 10 for the neutral. This is 2K times 10 for the neutral. This is going to be, since for the neutral is going to be 0, because why 0? It's a 240 load. Times 10. When you add them up, you're going to end up with 30K VA. And then you apply the demand factor here. You take the 30 kVA, multiply it by the same thing, 0.75. That will get you a healthy 22.5 kVA. Ladies and gentlemen, this is what you need to carry. Do you see how this step's slightly different, Adam? And I think you were working on it yesterday. When you pull these, anything 240, you have to do some math here. You can't just take that number because some of them don't count. Can you just see that this does not count for the neutral? Why? Because it's 240. It's not going to be seen by neutral. Anything that's 240, not seen by the neutral. Step number 11. Step number 12. Am I going too fast, too slow? Yes, no? Okay. Step number 12, guys. So that's easy. Step number 12, the motors. For the motors, I want you guys to look at these motors are running at 240 volt. Do you see any neutral with them? No. So when it comes to the neutral, you're going to put neutral, and it's going to be a big fat fluffy zero. Why? They're not running. But I should write zero there. So I know when you do the math for me, guys, get into the habit when you size a neutral, put zero so you know it doesn't count. The last thing, gentlemen, ladies and gentlemen, is going and adding them. Now we're going to go add them. Right here, I'm going to put them right next to each other. I have 50 in different color, 56K. This is a 23.7K. For this load, 21K for the dryer. For this load, it's 0 fluffy K. Is for fasten in place, it's 22.5K. For the motors, it's 0K. And we're going to add them up. Let me remove 304. Let me move them just slightly so I can put this one. 304 kVA. That was the size for the phases. For the neutral, when you add these up, guys, you're going to come up with 123.2. 123.2 kVA. That's the size you're going to use for the neutral. That's the size you're going to use for neutral. Piece of cake. Piece of cake. Okay, so you go now. You're going to go calculate. Did you go too fast? Everybody got that one? Yes, no? Cool. Karen? Good? Okay, so with the size and neutral, guys, what we need to do, so we got our amps. Now we need to size the amps. I'm going to do my calculation right here. So I'm going to find I equal, the size that I came up with, guys, is 123.2 divided by 240. Okay, so if you do the math on that one in green, it's going to be 513 amps. That's the amps of your neutral. So you're not going to size the panel or the overcurrent protection device for this amps. You're only going to size a neutral. Okay, so I have 513 amps. Everybody got that one? 513 amps? Yes, no? Cool. 513 amps. Now we're going to go all the way to the neutral. All the way to my neutral. Actually, I should have done it here. Oh, that's not a big deal. So, okay, so you go to this step to size that neutral. Here's what we're going to do. Now we have 513 divided by 4. Adam, why did I divide by 4? Yes, 4 sets. Can I divide by 3 the neutral and the phases by 4? No. If you parallel the phases 4 sets, what do you need to do in neutral? 4 sets. You put the phases or the hots 5 sets, the neutral have to be 5 sets. So how many runs you run the neutral depends on how many runs you run the phases. You can't just run 5 here and 2 here. No. Because every set has to have a neutral with it. Okay, when you do your math on this one, guys, you're gonna end up with 128.3 amps. If you take the math, take it to table 310.15 B16 under 75-degree column, same like we did with that one. You're going to end up with same thing, 4 sets, exactly. One conductor, number 1, AWG THHW. Okay? AWG THHW. Any comments, guys? Any questions? Any comments? Any questions? Any comments? Any questions? Oops. Okay. Now, Karen, there's one little problem. Can you parallel number 1? You cannot parallel number 1. The code says, guys, you shall not parallel number 1. Can't parallel number 1. The minimum that you can parallel is 1 out. So you're going to come down here again and says, because of paralleling, you need to have change your answer into 4 sets of number 1 conductor, number 1 at A W G T H H W. Can I ask you guys to, oops, there you go. And we need a 4 sets. So we have 4 sets. Let's see a little bit. 4 sets of this baby. Okay, so we have 4 sets. There you go. 4 sets of 1 out. That's all. Why? Because I cannot parallel less than 1 out. So you can't do it, even if you want to. Any comments, guys? Any questions? Any comments? Any questions? So we size the service entrance panel size, service entrance overcommunication device, ungrounded service entrance conductor, building service conductors. So that's the last one, guys, is main bonding jumper. When we size the main bonding jumper, I didn't ask you, but it was on the test to size the main bonding jumper. The main bonding jumper, this is how we size it. The last thing, main bonding jumper, because the neutral is also have to be, the neutral cannot be less than the main bonding jumper. Cannot be less than the main bonding jumper. The way you size this one, guys, you're going to take 4, multiply this one by 600. You guys remember that 600 kcm? That will get you 2400 kcm. Then you're going to take 2400 kcm, multiply it by 0.125, 12.5%. This is coming from 250.28, guys, all this. I didn't do the math on that one. 0.125 times 2400, yep, equal 300. Equal 300 kcm, 300 kcm. Okay, 300 kcm. That's the size of the main bonding jumper. That's the size of your main bonding jumper. That's the size of your main bonding jumper. Is 300 kcm a standard size? Yeah, if you guys go to table, chapter 9, table 8, 300 kcm is a standard size. So we hit the jackpot. If it wasn't the standard size, what would you do? You go to the next standard. You go to the next standard. So that's the size of the main bonding jumper. That's the size of your main bonding jumper. Now to size, that's the size of my main bonding jumper. Now to check, the NEC code book, guys, says, the NEC code book says the neutral conductor cannot be smaller than the main bonding jumper. So let's see, is it smaller? 4 out. 1 out, is 1 out smaller than 300 kcm? Yes. But don't let this fool you. We have 4 conductors of 4 out. So just to do a check, guys, for the neutral, what we typically do, you take the 300 kcm divided by 4. What's 30 divided by 4? What's 300 divided by 4? Anybody? 75, how much?
Okay, so it's really 75.
75 kcm. Now take this 75 kcm to chapter number 9, table number 8, will you? And give me the size. Why did I divide by 4? Because to compare apples to apples, we need 4 of these. We need to compare them apple to apples. Can somebody go, guys, there? I don't have the answer for that one. So if you go to chapter 9, table 5, table 8, I'm sorry. Chapter 9, table 8. Where am I here? Table 8. 75, yep. I have 52, 66. What would the size be? I'm looking 66K, that's number 2. 83, I have 83, number 1. So if you guys do that, surprise, surprise, you're going to end up here with one conductor, number 1AWG. One conductor, number 1. Have I paralleled? What was the size? That's just to check. What was my size to start with? My size we start with was number 1 anyway. So I'm okay here. And then I'm okay because I'm not smaller than main button jumper. But because we parallel, we jump up to 1 knot. That's all. So long story short, guys, if this number here that you came up with 2 aught here, the neutral have to be 2 aught. Okay, it's not on the test, but it will be on future tests for when you do commercial industrial. It becomes a big deal. You understand it now? Check. You don't understand it now? Coming in the commercial industrial, we'll do the same calculation, guys. That's all what I have for the calc. Any comments, any questions? Easy. There is no reason for you guys not to get an E on that one. Even have